Yeah, and I remember you talking about things. There's several things that were so fascinating. You talked about obesity genes, right? Some
Mhm.
people have the genetic predisposition to be obese,
Mhm.
and how certain populations have those genes, but because of the dietary adaptation, they're
Mhm.
not obese. So can you talk a little bit about that?
Yeah, sure. So I mean, it's funny, it's unfortunately named, but one of the strongest association-based genes to obesity is known as FTO, and it literally is called the fat and obesity gene. And
Mm,
while the clinical or the cellular mechanisms aren't 100% clear currently, what we do know from clinical studies is that the versions of this gene are strongly associated with a person's experience of satiety. And satiety is the feeling of being full, right? And so when you have a variation in this gene, your mind and your body don't communicate fast enough to let you know when you're full. And so you have a hard time knowing when you're actually full. And satiety is different from satisfaction. Like you can be full, but you're not satisfied. Like how many people are satisfied after eating a bowl of broccoli? They know it's healthy for them, but they're not always satisfied with the meal. And so they might look for satisfaction in the form of ice cream or something sweet or something just to satisfy their pleasure profile. And so when you have a variation in this gene, it prevents your mind from communicating fast enough with your body that you're actually full. And that encourages overeating, right?
mm,
And if you combine that, and here's where the functional genomics comes in, if you have a increased likelihood to overeat and you've got a pleasure profile that gets really, really excited, it binges on behaviors. Well, guess what? When it comes to your favorite meal, your pizza, your cheesecake, whatever it is, you just can't stop eating. Like it's literally genetically programmed for you to be able to, unable to stop eating. So we found that extremely interesting, and it points to one of the limitations of nutrigenomics is it's looking at a gene-based association. One gene, this thing, one gene, this. And what we're saying is when it comes to diet nutrition profile, before we even get to what you eat, it's like, why do you eat? How do you eat? Where do you eat? When do you eat? All these questions we have to ask because there's a huge psychology perspective to food. Now, going back to the population genetics, what we do find, this is the beauty of the epigenetic influence, right? The adaptations of populations. What we have found is one of the populations in the world with the highest percentage of risk for obesity from a genetic level are folks from Thailand, Laos, Cambodia, that Southeast Asian population. But if you were to sit here and think about the average Thai or Laotian or Cambodian person, you wouldn't imagine someone who's obese. In fact, you'd imagine the opposite, someone who's very thin and lean and, is easy, can easily put on muscle, for example. And when you study the palate or the food adaptations of these people, what do you find in their cuisine? Well, what you find is diversity and variety in the flavor profile, in the taste profile, in the sensory profile of their food, right? I always tell people, I say, how many pieces of fried chicken could you eat? Two, three, four, five, 6 pieces. How many plates of pad thai can you eat? Probably not more than one. It's almost impossible to eat 2 plates of pad thai because pad thai is designed to satisfy the person's palate, right? So if you think about the ingredients and the staples of pad thai, you've got the chewy noodles, you've got the umami fish sauce, you've got the sour tamarind and the sugar, and the crunchy peanuts that they put in there. So there's a huge complex experience that you're eating that your mouth is like, whoa, I am satisfied right now. Like I'm happy. And
Well,
so
by the way, I'm sorry to interrupt you, but that plate of pad thai will be considered, a lot of people would say, no, that's not healthy for you. There's so
and
much carb.
yeah, and it's not that it is, it's that you can eat a very small plate of pad thai and be satisfied and not have to eat anymore, right? That's the thing, that you could literally eat half a plate of pad thai and be totally fine with it. You don't feel like you need to eat a huge heaping bowl. The problem is people when they eat pad thai, they're, if you're building a mound of noodles, that's a big problem. But even eating a small portion of pad thai can be very effective. And if you apply that across the board, think about the most high-end luxury Michelin star restaurants or sushi restaurants. If you look at an omakase menu, it's exactly designed for satisfaction. It's like super small portions, but every bite has like umami and sour and salty. And it's like, it's this whole experience. So the mind and the mouth feel so satisfied that you don't necessarily need to eat a lot, right? So the Thai people have developed this, and the Laotian and Cambodian, their palate is designed for satisfaction very quickly. And so they don't actually eat a lot. If you look at their palate, even their eating mechanisms, they're not eating frequently, right? They eat very, very small portions, and then they move on with their day, and they have very difficult, most of them have very difficult, laborious lives. So you don't find a huge percentage of obesity in that population. But if you took a Thai person from Thailand and you put him in North America and you put him in front of a computer screen for 8 hours a day, and you gave him American-sized portions of pad Thai, he would go obese very fast. And that's the epigenetics. Because I changed him from his location in Thailand. It's under the heat. He's working outside. He's eating very small portions. And I brought him to America, and he's working 12 hours a day, and he's stressed out, and he's drinking garbage, Soylent or whatever it is. And he's eating huge plates of pad Thai because he's missing his home. He's most definitely going to have a much greater risk, and probably a faster reach to obesity than the average person, right? So it's that like change in epigenetic factors that can trigger and exaggerate a person's genetic